Good morning everyone. Today we are going to discuss about thermodynamics. One of the subtopic we have, that is thermochemistry. In thermochemistry mainly consists of two subtopics in thermodynamics according to NCERT textbook. Those are 6.4 and 6.5. Thermodynamics mainly consists of more the subtopics according to NCERT textbook means 6.4 and 6.5, both combinedly we call as what? Thermochemistry. Okay, na separate topics these two, and remaining topics will comes under chemical thermodynamics. These topics comes under what? Thermochemistry. So now we are going to discuss in detail about this thermochemistry only. So what is the first subtopic we have in this thermochemistry means, the first one is enthalpy change of a reaction, or we can also call as reaction enthalpy, right? Reaction enthalpy. So what is this reaction enthalpy? We know already that students, in a chemical reaction the reactants will be converting into products, right? Reactants will be converting into products means we can easily calculate enthalpy change, right? First of all, what is the meaning of enthalpy? It is the sum of internal energy and work form of energy of the system, right? It is the sum of internal energy of the system and work form of energy of the system. Already we have discussed in thermodynamics. So the enthalpy is H is equals to what? Internal energy of the system plus work form of the energy. W you can take it. Work form of energy is nothing but what? It is the product of pressure and volume work, right? H equals to U plus PV work only, right? This is what? Enthalpy of the system. Enthalpy is nothing but it is the sum of internal energy of the system and work form of energy, right? So enthalpy change of a reaction we are going to discuss. So that is nothing but how much enthalpy change occurred during the conversion of reactants to products. We are going to discuss. See that in a chemical reaction the reactants are converted into products here like this. So the enthalpy change accompanying a reaction during the conversion of reactants to products is nothing but what? A reaction enthalpy. This reaction enthalpy we can or else enthalpy change of the reaction we can represent with what? Delta HR. Delta H is nothing but enthalpy change of the reaction. Enthalpy change delta H is equals to H products minus H reactants, students. Enthalpy change delta H is equals to what? Enthalpy of products minus enthalpy of reactants. This is related to reaction, so that's why we have used the symbol for reaction R. Delta H is enthalpy change of a reaction, so that's why I kept here R. Okay, now enthalpy change of a reaction we can represent it by delta HR. How do we calculate that enthalpy change of a reaction? You see that, students, here enthalpy change of the reaction delta HR is equals to sum of enthalpies of products. Enthalpies of products minus enthalpies of what? Reactants. Why we have used here sums of? That means what? Reactants means not only one reactant, some of the reactions more than one reactant also present. That sum of all the reactants or sum of all the products. So sum of enthalpies of all the products minus sum of enthalpies of all the reactants is nothing but what? Delta HR. That is what? Enthalpy change of a reaction. We can also represent this one like this. Summation you can use instead of these terms. Instead of words you can also write in symbols. What is that means? Summation. AIH products. Meaning is what here? H products means enthalpy of products. All values we have to sum it. AI is nothing but stoichiometric coefficient of balanced chemical equation in which side? Product side. So stoichiometric coefficient of product this is, right? And here also same. H reactants is nothing but enthalpies of. Summation is there na? Sum of enthalpies of reactants. What is the meaning of BI sir here? BI is nothing but what? Stoichiometric coefficient of reactants, right? That how do we calculate and all we will see. Just I am giving to you formula. By using this formula we are going to calculate what? The enthalpy change of a reaction, right? Here AI and BI are the stoichiometric coefficients of products and reactants in the balanced chemical equation, students. Okay, na? Hope everybody understood. Copy this one. Let us see one of the example for this enthalpy change of a reaction. I have given to you combustion of methane. Combustion of methane gives carbon dioxide and water. We know already that it is a balanced equation. It is a balanced equation. So how do we calculate enthalpy change of the reaction for this reaction? Means we know we have the formula, that is summation of AiH products minus summation of BiH reactants. AI and Bi are the stoichiometric coefficients of products and the reactants respectively in the balanced chemical reaction. Yes? Yes. Now you see that H products means what? Enthalpy of products minus enthalpy of reactant. That some values we have to take if the reaction possesses more than one reactant and product. Now you see that here two reactants are there and two products are there. Then how do we calculate for such type of reaction enthalpy change of the reaction? I will give you an idea about this, right? Now you take here this, instead of this summation I have used this. See that according to this reaction, what are the products? CO2 and H2O, right? I am taking HM, CO2 gaseous state. HM means molar enthalpy. 1 mole only na, so 1 mole of CO2 enthalpy, right? Molar enthalpy of CO2 plus 2 means what? Stoichiometric coefficient. Here AI is what? With respect to H2O is 2, right? So 2 HM H2O liquid. So molar enthalpy of liquid first we have to take. For 1 mole we have to take which that value we have to multiply with what? The stoichiometric coefficient, right? So this whatever the enthalpy of corresponding product we are taking, that is related to only 1 mole. Molar enthalpy. The change in enthalpy per 1 mole is molar enthalpy, right? This is molar enthalpy we have to take value. That value we have to multiply with what? The coefficient. Then you will get what? The sum value is related to what? Summation of enthalpy of products we have got. Sum of the enthalpies of products minus sum of the enthalpies of reactants. The same thing you can apply with respect to CH4. Molar enthalpy HM of CH4 gaseous state plus 2 coefficient as it is I have written HM of O2 gaseous state, right? So sum of enthalpies of products minus sum of enthalpies of reactants is nothing but what? Enthalpy change of the reaction. Here HM is nothing but molar enthalpy, students, right? Molar enthalpy. I hope everybody understood. Copy this. Let us see, students, the change in enthalpy of a reaction. Enthalpy change of a reaction subtopics we are going to discuss. What is that means? First one is standard enthalpy of reaction. Enthalpy change of the reaction we have represented by delta HR. Enthalpy change means delta H, right? Delta H. Enthalpy change. Standard enthalpy of reaction or standard enthalpy change generally we represented with delta H naught. Suppose standard enthalpy change of a reaction if you want, you can take with R also. Standard enthalpy, standard conditions you are going to maintain means we have to represent it with a dot symbol. Dot in the sense this is what like a bubble, right? So like this we have to use. Whenever you have used the standard conditions, then only we have to use this symbol delta H naught. This naught symbol when we have to use only whenever you have used the standard conditions. What are the standard conditions, sir? Here standard conditions they have maintained 1 bar pressure and 298 Kelvin. If you measure the enthalpy change at 298 Kelvin and 1 bar pressure, then we have to use this naught symbol. In any condition means generally delta HR. Already we have used the same thing there. At standard conditions if you measure, then it becomes what? Delta H naught, right? That we have to identify. So what is the meaning of standard enthalpy of reaction means? The standard enthalpy of reaction is the enthalpy change of a reaction when all the participating substances means reactants will be converting into what? Products. Already we have discussed the enthalpy change accompanying a reaction is called what? Reaction enthalpy. The same thing only, but if you measure at a standard conditions, then we have to use what? Standard enthalpy of the reaction. So when all the participating substances are in their standard state, then we have to call standard enthalpy of the reaction. What is the meaning of standard state, sir? We may ask a question here. Standard state. Standard state, you see that this standard state we are going to discuss. The standard state is nothing but the most common physical state of a substance. Suppose some substance you have taken the reactant side. What is that substance physical state? Whether it is in liquid state or gaseous state or solid state, that you have to mention very clearly in the bracket with a small letter, right? So the most common physical state of a substance at 1 bar under 298 Kelvin is called what? It's a standard state. Okay, right? So the enthalpy of an element in its standard state generally they have taken as what? 0. Experimentally they have proved this, right? The most, see that, the enthalpy of an element in its standard state they have taken as what? 0. So what are that standard states are? How do we get to know? Some examples I am giving to you here. You can also observe in the textbook they have given very clearly along with molar enthalpies. If it is elementary form, then the molar enthalpy of that element, a particular element, they have given 0. If it is compound form, some values are there. You need not to remember the values. Only in elementary form, if it is there in the standard state, then they have taken enthalpy of that particular element, they have taken as 0 in its standard state. Standard state meaning I said to you very clearly the most common physical state of a substance. The most common physical state, how do we get to know means I am giving to you some examples for understanding purpose. Let us see now some substances standard state. Suppose if you take H2, H2 most common physical state of H2 is what? A gas. Everybody knows it. That means you need not to write again gas. After H2 just you put a G, small g like this you have to put while writing the equation, right? O2, the most physical common state is what? A gas. N2, nitrogen gas, right? Bromine, everybody knows it's bromine liquid. Mercury is also liquid. Liquid metal, liquid non-metal this is, right? Iodine, solid. The most common physical state of iodine is what? Solid. Carbon. Carbon we have various forms. What are those? Diamond, graphite, C60, that is Buckminster fullerene. Like this we have different forms. In that, which is the most common state means graphite. Graphite is the most common state. Whenever they have used the symbol carbon in the reaction, they have to mention very clearly graphite. Then only it is a standard condition we have used. Right here, if they mention after carbon in bracket graphite, then that particular element enthalpy we can take as what? 0. In rest of the conditions, it should not be 0. That will be different. Only in the case of graphite, the element enthalpy is what? 0 in its most physical common state, right? Yes. So carbon standard state is what here? Graphite, right? And sulfur, also if you take sulfur, different forms of sulfurs we have. Alpha sulfur, beta sulfur, like this. Rhombic sulfur, monoclinic sulfur, like that we have different forms of sulfur. Among that alpha and beta sulfur, that is rhombic sulfur is most common state, standard state they have taken. Next, phosphorus. Phosphorus also we have different types of phosphorus. What are those? Black phosphorus, white phosphorus, red phosphorus, different forms, allotropic forms. These are all what? Allotropic forms of phosphorus we have. Among that, phosphorus, black phosphorus they have taken as a standard state, students. HCl, generally we think about HCl is a liquid, but the most physical common state of HCl is what? Gas. This is not an element. Only in case of elementary form, they have taken its enthalpy is 0, but it is not elementary form, it is compound form, its enthalpy is not 0. Just I am going to tell you what is the physical state, most common physical state. Most common physical state of HCl is what here? Gas, not a liquid. Generally we think here it is a liquid, but they have taken as what? Gas here. CO2 gas, everybody knows. Water liquid, benzene liquid, ethanol liquid, naphthalene balls solid. Everybody knows it's remaining. Only in this case you may get doubt. And phosphorus you don't know, sulfur you don't know, carbon you don't know. Remaining rest everything you know already that. Just you have to keep in our mind while solving the numericals. It may be useful also, right? It's a standard states. Identifying whether they have given in a standard state or not. Okay, na? I hope everybody understood, students. You can copy this. Let us see, students, the next subtopic of enthalpy change of a reaction, that is enthalpy changes during phase transformation. In the word itself having the meaning phase transformation. Whenever the substance changes its physical state, one form to another form, then how much amount of enthalpy changed, that we are going to calculate. You see that generally we calculate at atmospheric pressure or else at 1 bar pressure. Generally we calculate, right? Start at constant pressure only we have to measure. So at atmospheric pressure, the amount of heat required or released when 1 mole of substance changes its physical state or phase. This is physical state or phase means, suppose I am giving to you one example for easy understanding only. You need not to remember the value, just you identify. Okay, na? You need not to remember the values. How many values we can able to remember? If you observe molar enthalpy changes values, in the textbook they have given plenty number of compounds. We cannot remember. If they want to ask based on this topic numerical, definitely in the bracket they will give the values of enthalpy of various compounds or elements. If it is element also they will give 0, or else element means we know it. Based on the standard state we can identify as this molar enthalpy is 0. Molar enthalpy of compounds means we cannot able to remember. So that's why you need not to remember the values. So if anywhere it is required, that I will inform you. What values you have to keep in our mind, what they will not ask, or else what they will not give in the numerical and all, right? Here the values are not required, just you have to identify the definition of this. At atmospheric pressure, the amount of heat required or released when 1 mole of substance changes its physical state or phase is called what? Enthalpy of phase transition, right? Suppose I have taken carbon, generally it is in solid state. If you want to convert carbon to solid state substance to gaseous state substance, how much amount of heat is required to convert solid to gas? Means we have required plus 1439 kilojoule per mole. This is kilojoule amount of energy is required. Kilojoule amount of energy is required. This much amount of energy, right? That is the meaning of what? Enthalpy of phase transition. Sometimes we may get allotropic forms also. So with respect to allotropic forms also, so the same thing only definition. The amount of heat required or released when 1 mole of an allotrope is converted into another allotrope of same element. Then we call that is what? Enthalpy of allotropic transition. You see that allotropic forms of alpha form, beta form I said to you. If you want to convert beta form to alpha form, how much amount of energy is released? It means minus 2.5 kilojoule per mole amount of energy is released. Right? So this is the meaning of what? Enthalpy changes during phase transformation. We have different types of enthalpy changes of phase transition. What are the types, main types of enthalpy changes of phase transition means we have in the syllabus. What are those means? Standard enthalpy of fusion. This is fusion. Standard enthalpy of vaporization. Standard enthalpy of sublimation. These are all we are going to discuss in detail by taking one by one, students. Here, first one is what? Standard enthalpy of fusion. We will take and we will discuss. You copy this one. Let us see, students, different types of enthalpy changes we have seen. That first one is standard enthalpy of fusion. What is the meaning of fusion means? It is a process in which the solid substance converting into a liquid, just like water melting only, right? So this standard enthalpy of fusion, how do we represent means? Enthalpy change represented with delta H. Standard condition, so standard conditions means we have to represent with delta H naught. Fusion process, FUS. Delta H, enthalpy change of a reaction means delta HR we have used, right? Enthalpy change of fusion means delta H FUS. Standard enthalpy of fusion means delta H naught FUS. Standard condition we have used, that's why we have to take here not. Fusion, so that's why FUS. For a different process, different words we have to use here. Whatever it may be, enthalpy change in standard condition means delta H naught is common. Only depending upon the process, here the words we have to take. FUS when we will take in case of fusion. In case of sublimation, SUP. In case of vaporization, VAP. Right? VAP, vaporization. In case of reaction, R. In case of like that, depending upon the sentence, we will take the symbol. Right? So now you see that. What is the meaning of standard enthalpy of fusion? The enthalpy change that accompanies melting means solid will be converting into what? Liquid. Melting of 1 mole of a solid substance in standard state is called what? A standard enthalpy of fusion, students. It is also called as what? Molar enthalpy of fusion. Means for 1 mole we are going to calculate. For 1 mole we are going to calculate, and that's why we are calling also as what? Molar enthalpy of fusion. Molar enthalpy of fusion also the same symbol only. Delta H naught FUS. For example, you can take water. Ice only I have taken. Ice generally it will be in the solid state. How it will be converting into liquid? By absorbing some amount of heat. Means the reactions in which the amount of heat is absorbed is called what? Endothermic reaction. So that's why this type of reactions are we call as what? Endothermic reactions only. Because the solid substance, how the solid substance will be converting into liquid? By taking heat only, generally, right? So that's why all these reactions comes under what? Endothermic phenomena only. So here solid substance, solid ice will be converting into liquid water. How much amount of heat is absorbed means 6 kilojoule per mole amount of energy is required to convert 1 mole of solid ice to 1 mole of liquid water, students. So 1 mole we have calculated, that's why we are also calling as what? Molar enthalpy of fusion. This is right. So suppose if you want to take reverse process, liquid will be converting into solid means that is what? Freezing, right? So now you see that if water freezes, then what will happen? Then the process will be reversed and equal amount of heat is released. Equal amount of heat is released to the surroundings to convert a liquid water to solid ice, right? Same amount of heat, here it is absorbed by solid ice. In the reverse process, it is released by liquid water to the surroundings to convert liquid water to solid ice, students. So then the process is reversed and equal amount of heat is given up to the surroundings. The same only if you want to take a backward reaction, delta H naught fusion, instead of fusion, freezing we have to take. Freezing is equals to minus 6 kilojoule per mole you will get in case of freezing. In case of fusion, this is the value. Okay, na? You need not to remember the values, just I am going to tell you how. Just I have given, so they have practically measured and they have given the values. All values we cannot able to remember. Just you have to observe whether it is endothermic phenomena or exothermic phenomena. If delta H value is positive, then it is endothermic. If delta H value is negative, then it is exothermic reaction. What is endothermic reaction and exothermic reaction? Already we have discussed in chemical thermodynamics there. Endothermic reaction means the reactions in which the amount of heat is absorbed. Such type of reactions we call as what? Endothermic reactions. And the reactions in which the amount of heat is liberated by the system, then such type of reaction generally we call as what? Exothermic reactions. So here delta H value is positive, so that's why such type of enthalpy changes generally we call as what? Endothermic, right? So melting of solid is endothermic phenomena, right? All enthalpies of fusion are positive only. Delta H values are what? Positive only, because to convert solid to liquid generally it should take some amount of heat. It should absorb some amount of heat. Then only it will be converting into liquid, students. This is about what? A standard enthalpy of fusion. Copy this one. Let us see the next one. Standard enthalpy of vaporization. So standard enthalpy of vaporization is represented by delta H naught vapor VAP. Vaporization is nothing but what? The process of conversion of liquid to vapor is called vaporization. In the similar manner, how do we define with respect to standard enthalpy? Means you see that the amount of heat required to vaporize 1 mole of liquid at constant temperature and under standard pressure. Means standard states we have taken. What are the standard state? The most common physical state of a substance at 298 Kelvin and 1 bar pressure is called what? Standard state. Here also we have used standard states. 1 bar pressure and a constant temperature means generally we will take at a 25 degrees Celsius, which is called as what? 298 Kelvin, students, right? So the amount of heat required to vaporize 1 mole of liquid at constant temperature and under standard pressure, that is 1 bar pressure, is called what? Standard enthalpy of vaporization, right? It is also called what? For 1 mole only we are calculating, so that's why molar enthalpy of vaporization also we can call. So one example I have given to you: liquid water will be converting into water gaseous vapor, that is a steam. To convert 1 mole of liquid water into 1 mole of steam, how much amount of heat is required? Means plus 40.79 kilojoule per mole amount of heat is required to convert 1 mole of liquid to 1 mole of water vapor, students, right? This is what a standard enthalpy of vaporization. And in the similar manner we have standard enthalpy of sublimation process. Everybody knows it. What is the meaning of sublimation? Sublimation is nothing but the process of conversion of solid to gas directly without reaching liquid state, right? Such type of process generally we call as what? A sublimation process. What are the sublimating reagents? Means we have many. What are those? Carbon dioxide and ammonium chloride, and we have one more iodine, naphthalene balls and ammonium chloride. We have the camphor, different compounds we have. In that some of the examples you will see. With respect to standard enthalpy of sublimation, how do we define? Means the same thing only, the change in enthalpy when 1 mole of solid substance sublimates. Sublimates means what? The conversion of solid to gas directly, sublimates. Solid substance sublimates at constant temperature and under standard pressure, that is 1 bar pressure, right? That process, that change in enthalpy we can call as what? Standard enthalpy of sublimation, students. Some of the examples I have given to you. Solid carbon dioxide. We know what is the name of solid carbon dioxide. Sometimes they are asking for 1 mark. Very important question. What is a dry ice? Dry ice is nothing but what? Solid carbon dioxide gas. Solid carbon dioxide is called as what? Dry ice. Here, so to convert solid carbon dioxide to gaseous carbon dioxide, how much amount of heat is required? Means 25.2 kilojoule per mole amount of energy is required. To convert a solid naphthalene balls to gaseous naphthalene, how much amount of energy is required? Means 73 kilojoule per mole amount of energy is required. So that's why this process will take place very slow. Now to convert a solid naphthalene to gaseous naphthalene will take place much time. So that's why amount of energy is required more. So now you see that iodine solid iodine substance to convert to gaseous iodine substance, how much amount of energy is required? 60.2 kilojoule per mole amount of energy is required, students. These are some of the examples for various forms of standard enthalpies, right? And this continuation we will see. First to copy this. Here we have discussed about various types of standard enthalpy changes. That is what? Standard enthalpy change of fusion, sublimation, and freezing, even vaporization, like that we have discussed some of the examples also, right, students? Here, depending upon the intermolecular forces of attractions between the molecules, the magnitude of enthalpy change we can identify. See that the magnitude of enthalpy change mainly depends upon what? The strength of the intermolecular interactions in the substance undergoing the phase transformation. Suppose if solid converting into liquid, different types of solids we have, right? To convert into liquid, that will be depending upon the substance, the magnitude value will change, right? For example, we will see that the amount of heat required to vaporize 1 mole of water is more compared to the amount of heat required to vaporize 1 mole of acetone, students. Here, water is also a liquid, acetone is also a liquid. So both the liquids are converting into what? Vapors. The enthalpy change, the standard enthalpy of vaporization, if you observe, in case of water it is more compared with acetone. Why? Is there any reason? Means yes, that will be depending upon what? Strength of the intermolecular interactions in the substance. strength of the intermolecular interactions in the substance. How it is, we will see that. For example, if we take water, because the strong hydrogen bonds between water molecules, between water and water, hydrogen bonds are present like this. Suppose if we take water molecule, the strong hydrogen bonding is present between the water molecules like this. Strong hydrogen bonding. Hydrogen bond is represented with water dotted lines. Whereas in case of acetone formula is what? CH3, C double bond O, CH3, right? Here, due to polarity among carbon and oxygen is more electronegative. Here it gets a partial negative charge, here it gets partial positive charge. Means dipole is created, right? So dipole interactions are developed in case of acetone. So dipole interactions are significantly weaker than strong hydrogen bond forces, right? So because of that reason, here you see that because the strong hydrogen bonds between water molecules hold them tightly in the liquid phase. So liquid phase they will hold, all the liquid molecules are held by the strong hydrogen bonds. So that's why to vaporize that liquid molecules, more amount of heat is required. But in the case of organic liquids such like acetone, the intermolecular interactions or dipole interactions are very significantly weaker. So that's why it can easily vaporize with the less amount of heat only, students. So because of that reason here, the amount of heat required to vaporize 1 mole of water is more compared with water amount of heat required in case of to vaporize the acetone, 1 mole of acetone, students. I hope everybody understood this. Like this we will discuss remaining forms also. We have the next concept we have, that is standard enthalpy of formation and thermochemical equations we have, students. We will discuss all these topics in the next video, students. Okay na? I hope everybody understood. Copy this one. Thank you.